Okay, shall we get started?
Yeah.
Okay, perfect. So, nice to meet you. Nice to meet everyone. For those of you we still don't know, my name is Jeremy Gata. I'm the export manager for Adeunis, and with me today I have Elsa Bernard-Moulin.
Hello, everyone. Thank you for joining us for this webinar.
So today, as you already know, we are going to talk about our latest device, the cellular field test device by Adeunis. We are going to tell you a bit more about the specificities of the product, the technical aspects, and show you also how it can be used directly on site by you, your partners, or your customers. So moving on to the next slide, we will show you the agenda for this morning.
So here is what we've planned for the next 45 minutes. So first, Jeremy will start with a short introduction, presentation of Adeunis. We will also introduce the main challenges in network analysis and show how the Adeunis tester can address them. And then we will work through the live demo to showcase its real-world capabilities. And we will conclude this webinar with a Q&A session. So let's get started.
Perfect. So also, if you have any questions, you can write them down in the chat. We will have a dedicated portion at the end of the webinar, of course. So a quick few words about Adeunis for those of you who do not know the company. We are a French company, a French device-making company for IoT solutions. We have been around, as you can see, for about 20 years or so now. We are mainly focused around three main segments, which are the smart building, the smart industry, and the smart city divisions. So as you can see on the next slide, we are using just a couple of pictures to show you what we do. This is a building, and from the bottom to the top, we can see all the use cases that we mainly cover with our sensors. So the three main sectors in which we operate are energy efficiency, process optimization, and we call it user comfort, but really it is indoor air quality, such as temperature, the humidity, small particles, VOCs, etc. So we are here to provide sensors to an already existing solution for BMSs. And today we are going to talk about our radio mapping tool, the field test device. Moving on to the next slide, we are going to talk about the main challenges in IoT deployments that we have witnessed over the years. The four main ones, as you can see on the screen right now, are the inconsistent network coverage that you can face when being on site directly, the complex and time-consuming process that it can be to install sensors on site, the lack of actionable data also for network optimization. As we all know, it's very important. And last but not least, the difficulty in troubleshooting connectivity issues and knowing how to fix the connectivity problems. So we are going to start with a question first. Normally, everything should work fine. How do you currently validate the network coverage before deploying your IoT devices or your customer IoT devices? So now you should be able to see a questionnaire on the screen. If you will, we are going to leave you half a minute to fill in the questions and answer, and then we'll take a quick look. Okay, we have some answers already. Let's give a few more seconds. And it's already interesting. Perfect. Okay. A few more seconds, and then we'll be good to go. I see that some people are still replying. Yeah, we have a bit of time, to be honest. That's okay. Okay. Okay, there we go. So I'm going to share the results of the vote. I hope everyone had the time to respond to everything. The idea is just to get an overview of you are several types of attendants. We have network operators in the chat. We have integrators, distributors, and customers. So really the point is to see for each medallion of the value chain how you view IoT deployments in general. So let me share the results. We can see right now, yeah, half of half of the attendants have participated. That's perfect. So as we can see, the main questions I'm interested in myself is the first one and the second one. But as you can see, there's not one way only one device to use. There's not one way to do placement of the devices, or there's not one challenge being faced by everyone. We have different ones. So that's actually why we wanted to show this quick quiz to link up with the following slides. So I'm going to close the questionnaire now that we will keep ourselves. And Elsa will share the presentation once again. So we'll stay on this slide for now. The point of this questionnaire was to address several topics. I'm talking about the export business mainly, but from our discussions with customers, we found that many use one of the following approaches when it comes to IoT deployments and radio mapping. You can have the manual sensor placement, which is not the best, but sometimes it's all you have as an option. So some teams install sensors at multiple locations and they test connectivity one by one, which is time consuming, as you know, and often not efficient enough. Then you have the basic mobile network test, specifically for these technologies, narrowband IoT and LTE-M, of course, where you rely on a smartphone to get a rough estimate of the signal strength. But this method, the problem is that it lacks precision and accuracy for professional deployments. So if narrowband IoT and LTE-M, it is true they share the same infrastructures, which is 4G and 5G towers, for instance, they operate completely differently. Narrowband IoT and LTE-M use dedicated frequency band and resources blocks within the LTE spectrum, for instance, and it's optimized for coverage and penetration rather than for speed. And it ensures better performances in challenging environments such as basement, concrete floors, remote areas, hard to reach areas, compared to standard LTE. Smartphones, on the other hand, they connect to LTE or 5G networks, which has a higher throughput and a lower latency. So often it requires a robust signal conditions, and it's more susceptible to congestion because all the phones are using it already. So narrowband IoT and LTE-M network, in a nutshell, they use different protocols and resource management than our traditional 4G, 5G networks, even though they share the same, quote unquote, physical infrastructures. So this difference ensures that IoT devices can operate in scenarios where a smartphone might struggle to do so. The third way is the trial and error with live devices. It's a common practice that involves deploying live IoT devices, such as our sensors or also smart meters, and waiting for connection issues to arise. It's a reactive approach, but it leads to costly delays and additional site visits. And the last one is the external contractor option, where you hire an external company, in some cases, network specialists, usually, to conduct detailed surveys, which can also, of course, add to project costs and timeline. This is why we think the field test device by Adeunis can be your go-to tool, as we can see in the next slide. There we go, perfect. We have several reasons to think that our devices sets itself apart by mainly its ability to provide actionable data in real time, all from a single portable device. Normally, yes, you can see it, for instance, here on the camera. You don't have to revisit the location of your project. You don't have to do some guesswork. It's an all-in-one solution, really, for network validation. Let us explore how right now. A few words about the field test device, narrowband IoT and LTE-M by Adeunis. It is a portable Bluetooth-enabled network tester designed specifically to analyze narrowband IoT and LTE-M networks in real time. These networks, as we have said, are optimized for IoT applications, of course. They are focusing on low power consumption, extended coverage, and reliable data transmission for small payloads. Unlike smartphones, as said before, that prioritize high speed and low latency, the narrowband field test device is tailored for use cases like deploying sensors, smart meters, and we can say IoT devices in general. It offers 3 operating modes that are very distinct and make the Adeunis field test device incredibly versatile, whether you're conducting quick scans, detailed tests on a specific network, or building a whole comprehensive project report. Elsa will tell you a bit more about this later on, but in a nutshell, let's take a closer look at what makes this device an essential tool for IoT deployments. The first one would be real-time network analysis. As we said, our field test device provides accurate, instant insights into both or either narrowband IoT and LTE-M networks. It measures critical parameters that we'll get into detail in a moment. Also, it's just one device, with a phone, of course, for all available telecom networks at the moment. You don't have to complicate yourself with multiple tools. One of the most powerful aspects of the device is it's universally compatible, which means that you can evaluate all urban IoT and LTE-M networks with a single tester, this one. You can test any network anywhere. It supports all the global bands at the moment and all the main telecom operators, as long as you are using a nano-SIM card. And telecom operators, for instance, such as the main ones in Europe, at least, Vodafone, Orange, AT&T, T-Mobile, and all the others are supported. This will save you time and money. You don't need to purchase several devices to do that. You can streamline all your operation with one device. Then we have what we are actually very proud of, which is the user-friendly portable mobile app that our FTD will pair to through Bluetooth, like I said. The design keeps the device compact. It's lightweight, of course, because it's meant to be used outside during the radio mapping. It's battery efficient, which extends its operating time as well. The app features a user-friendly interface that you will see in just a moment, allowing you to configure tests, visualize the results in real time, and export data as well. From quick scans to detailed reports, everything is accessible, in just a few taps. So additionally, the smartphone provides, of course, geolocation services for mapping measurements, which are critical in network planning and deployment. The portable design part as well mentions really the hardware side of the field test device. Like I said, it's compact, it's lightweight, ideal for field work. It has an intuitive control system. It is really straightforward. It's a power button, a test button, a few LEDs to indicate the Bluetooth connectivity and the battery status. And it has a battery life exceeding up to 15 days of battery life and a USB-C fast charging. So you won't have any more problem being ready for your next test. And last but not least, the professional reporting tools, of course. With the device that we designed, you are not just testing networks, you are also documenting them. And this is really important. With the GPS location, geolocation, you have the ability to add photos, comments for measurement points, and customizable parameters, but I will not say too much about it because Elsa will show you right now what you can do with the device.
Okay, thank you, Jeremy. So now let's break down the 3 operating modes of this field test device. So first, we have the network scan mode. This mode helps you quickly assess the network availability and identify the nearby NB-IoT or LTE-M cells, making it perfect for an initial evaluation. With this mode, the network scan mode, you can scan all the networks within range or limit the scan to those supported by your SIM card. You can analyze 2 key metrics of network coverage in real time, the RSRP for the signal strength and the RSRQ for the signal quality. And you can view detailed operator information, including the MCC-MNC code and the cell ID, for example. So this mode provides a high-level overview, allowing you to identify the best operator and technology in an area before conducting deeper analysis. So the second operating mode is the network test mode. This mode is ideal for in-depth analysis to help you test network quality at specific locations. So here is what you can do with the network test mode. You can customize your test parameters. For example, you can choose the operator or the technology, NB-IoT/LTE-M, that will be used for your test, but you can also choose the test intervals, for example. You can decide to run tests manually or automatically based on your needs. And you also have access to detailed metrics in real time, like the C levels, the transmission power, the EDRX, the PSM parameters, for example. And you can also use the averaging function to perform multiple tests and calculate more accurate results. So this mode, the network test mode, provides deep insights into the performance of a network, helping you to make data-driven decisions about the sensor placements and telco network selection. And finally, we have the radio mapping project mode. This is our most powerful and professional feature. This mode allows you to contextualize network tests by associating test results with GPS locations on Google Maps or indoor building plans. and also by adding photos, comments to your measurement points for a more comprehensive analysis. So once your project is complete, you can generate a Word report that will compile all the project details, including results, geolocations, and your observations. So the radio mapping project mode is particularly useful for large-scale deployments, for example, at a city level, as it allows you to document the network quality in a way that is really easy to share with anyone.
So now we're going to talk a bit more about the real-world applications of our field test device for the cellular technologies. Elsa has presented a bit about the device already. She will dive a bit more into the technical features of our device in just a moment. But in the meantime, now that we have explored those features for a bit, let us see how it's making a difference in real-time IoT deployments, actually. So for a lot of you, these examples will sound common, but they showcase the versatility of our field test device across different industries and different environments. The first one, as you can see, is smart metering deployment, which I think is one of our biggest one, actually. As you may know already, one of the biggest challenges in smart metering is ensuring the connectivity in difficult environments. For instance, basements, underground installations, and everything. Our utility customers usually use the field test device to either validate coverage before installation. That will be the main use case, I think. Thus ensuring that smart meters or sensors communicate reliably in those hard-to-reach areas. They also identify the best antenna placement for maximal signal strength. For anyone that has already done radio mapping and sensor installation, you know that sometimes a few centimeters of difference in placement can result in a way better radio signal. And the third thing about smart metering would be, in a nutshell, reducing the deployment issues by about 40% from what we've witnessed, to make sure that the installation team will perform a quick and efficient job on site directly. Moving on to the industrial IoT side of things, usually the locations can be, it's a bit cliche, but it can be a factory, a warehouse, challenging environments with often metal structures, concrete walls, reinforced steels in terms of floors or walls as well, and a lot of machinery causing signal interferences. The field test device in this case can allow the team to map indoor coverage accurately in often big buildings, identify the dead zones within the building to avoid unnecessary cost of installation, optimize the placement of sensors, or as well, compare operator performance, because we are talking about nano-IoT and LTE-M. So you also need to compare operator performances to choose the most reliable network for each given location of your site. And then finally, the smart city applications. Elsa mentioned large-scale IoT deployment, which I think is really fitting. You can have street-level sensors, underground installation. The smart city customers that we work with, they rely on this device to conduct street-by-street signal testing for city council, for instance, that needs to implement a whole district. They compare multiple operators as well to select the best option for citywide deployment, which is no small feat. They validate underground coverage, for instance, for parking sensors or utility meters as well. And they can, thanks to the last option of the last feature of our device, generate professional documentation for city authorities. More often than not, you have several teams working together. With this device, you can generate a common document and share it with all the relevant people to streamline project approval and gain a lot of time, for instance. Like I said, those use cases can seem a bit common, but they demonstrate how our field test device can help deploy faster, reduce the costs, and also, last but not least, once again, ensure optimal network performances for any IoT project. So now we will go a bit more into practice. We'll demonstrate the field test device in action with a few videos. We will show the ease of setup once you receive our field test device and demonstrate the 3 core modes that myself and Elsa talked about, which are, once again, the network scan, the specific network tests, and the radio mapping projects. And finally, we will highlight the professional-grade features of the device, such as exporting a report in real time.
Thank you.
Up to you.
Okay, so now let's go first over the setup process for this tester. So one of the strengths of the FTD is how quickly you can get it up and running, even for first-time users. So it's designed really to be intuitive, with minimal steps required to start testing. So the first step for you will be to download the Adeunis app from the App Store or Google Play. This app is completely free and you don't need to register to use it. So once the app is installed, this app will become your control hub for configuring the FTD and viewing test results in real time. So I invite you to watch the video I'm about to launch on the tester startup process. So when you have downloaded the application, you can insert your nano-SIM card into the device. You just need to follow the diagram on the device to correctly insert the nano-SIM. And the field test device supports any operator worldwide, as Jeremy mentioned, so you can easily switch between operators as needed. To turn on the device, you just have to hold the power button for 2 seconds, and you will see the green LED on, indicating that the device is switched on, and the blue LED lights up, confirming that the FTD is ready to pair via Bluetooth. So to start the pairing process, you need to open the app on your smartphone and to enable Bluetooth. The app will scan automatically for nearby FTDs, and you will see a list of available devices. And you simply have to select your FTD, which you can identify by the serial number printed on the back. So with the FTD paired, you will be able to use the app to configure the network settings first. So for example here, the network selection mode or the technology to use for network connection can be configured. And with this intuitive interface, it makes it easy to set up and save these parameters for future tests. So that's it. The setup process takes less than 1 minute, as you've seen, and the device is now ready for action. So you can start scanning networks, configuring and running tests, and collecting all the data with just a few taps on your smartphone. Okay, so now let's see the network scan mode in action. So as I mentioned previously, this mode provides you with a quick overview of all the NB-IoT and LTE-M networks within range. So here again, you can watch the video I'm about to launch to show you the scan mode. Okay, so first you need to navigate to the network menu in the app. And once connected to the mobile application, the FTD automatically attaches to the network based on the SIM card inserted. So if it's a single operator SIM card, the device will connect to the only authorized network. And if it's a multi-operator SIM or multi-technology SIM card, the device automatically searches for and selects the best operator or technology to establish the connection. So if you can directly carry out a network scan with the current network parameters, or you can change the configuration of technologies and frequency bands via the mobile app, as it's displayed on the video. So now you're ready, you can click on Scan Networks, and you can choose between 2 options: to scan all the networks or to scan only the networks that are supported by the SIM card inserted inside the device. And now the application indicates the network parameters that will be applied to perform the network scan, and also an estimation of the time required to perform the scan. So you just have to click on yes, and the scan will start automatically. And the scan results will be displayed on the video and on the app, on the application, just in a few seconds. So for this demo, I have inserted a SIM card provided by the French telco SFR, but you will see that the device, the tester, not only scan and assess the SFR and the IoT and LTE-M networks, but also the networks of the 2 other telcos we have in France, Bouygues Telecom and Orange. So for each operator and network available within range, the scan results show a visual quality indicator for the strongest cell, as well as the total number of surrounding antenna that are scanned. And you can use the arrow to display details and performance for each antenna. So you can have a look at the performance of SFR, for example, NB-IoT, Bouygues Telecom LTE network. And you can also export the results of the last scan as a CSV file directly from the mobile app. So a quick scan really gives you an immediate insight overview of the network availability, network performance, in order to identify the best operator and the best technology for your project. And next, let's take a look at the network test mode. So this mode is ideal for analyzing the network quality for a specific operator at different locations. So with this mode, you can customize parameters such as the operator, the technology, the test intervals, and you can also run manual automatic tests depending really on your needs. So I invite you once again to watch the video I'm about to broadcast, and I will provide you with additional comments as the video progresses. So if the network settings have been configured already, you are ready to configure the test parameters. Otherwise, you can modify the network settings via the network menu. So to configure the test parameters, you just have to click on the icon on the top of the screen, and the tester this tester really goes beyond standard network testers by offering fully customizable testing parameters. So you can set up the test mode, for example, manual for one-time measurements or automatic for continuous monitoring. You can focus on testing only one technology, NB-IoT or LTE-M or both technologies to match your project requirements. The quality of the signal received from a cellular network is not static over time and can vary. So for more accurate assessments of the network, the tester also has an average function that you can activate, enable, and this function allows you to perform between 5 to 10 successive tests each time you trigger the test button. And of course, you can select the network parameters, network quality, measurement data you want to display on the app and also to export as a CSV file. So as you can see, we have a lot of parameters that can be enabled on the app, really to cover any needs you have for your project or customers. And all these settings, they will remain active during subsequent power up as long as you do not configure new settings. So in this video, I have configured a manual test. It means that I need to press the virtual button on the mobile app or the button on the front of the tester. Each time I need to trigger a network test. And the results of the test, once again, they will be displayed in real time in the app and grouped into 5 different sections that you can see on the video. So in my configuration, I have chosen to test the 2 technologies, NB-IoT and LTE-M. I have one screen for NB-IoT test results and another one for LTE-M test results. And if you are setting up an automatic test, you just have to press the start button on the mobile app to trigger an initial network test. And then the device will automatically trigger the subsequent test according to the measurement interval you have configured from 30 seconds to 24 hours. And the results are displayed and logged continuously by the mobile application. So to summarize, the network test mode allows you to gain a deeper understanding of the network performance at specific locations, different locations, and you can also export all the test results in CSV format, or you can also send them to an HTTP server for further analysis.
And for instance, about the recurrent testing, as a small anecdote, we went to Italy. I think it was in November last year for the NLIT exhibition that some of you may know, and we took with us this device to test the coverage. So we also implemented recurrent testing, I think it was, and one testing every, I don't know,
10 minutes.
10 minutes, yeah. So from France through the Italian border to Milan in Italy. And the results were really interesting. So that's only one of the things that you can do with the device. Sometimes we have people that do radio mapping by car in a big field, for instance, or a large complex. You can take the device with you in the car, set up the automatic transmission testing, and then have an idea of several points, GPS locations without having to move from your car, pretty much, which is quite cool.
Yeah. Okay, and so finally, let's explore the radio mapping project mode, which is ideal for large-scale deployments, projects requiring detailed documentation. So this mode contextualizes the network test by associating them with geolocation, photos, comments. So to begin, let's take a look at a video showing the creation of a new radio mapping project. And just to let you know, a new project can be created before a site visit, even if the tester is not connected to the mobile app. So you need to go to the project menu in the app and click on New Project. And you will be guided through 5 steps to create your project. So first, you will need to fill in general information about the project, such as the project name, site name, the name of the end customer if you want. You can define a project start date. You can add another picture, even if you want. Then you can configure the test parameters for this specific project. So select the technology to evaluate, select the parameters you want to test, network quality parameters you want to test, and save for this project. Third step is to the configuration of the network that will be used to carry out the test as part of this radio mapping project. So you can select the band, select the technology. So at this stage, you have to indicate the location of the site on which the radio mapping project will be carried out. And you can also import building plans if you need. So as you can see, setting up a new project is quick, straightforward. And once the project is created, you can start adding geolocated measurement points just by clicking on the network test button. And then you can add contextual details to document the network test. Okay, so now let's switch to another video with a pre-existing project to really explore what the radio mapping project mode can do once you have added measurement points and collected data. So when the radio mapping project is opened on the application, the connected tester will automatically apply the and the network parameters that you have configured at project creation. So in this project, you can see multiple measurement points already logged, each with detailed data, photos, comments. You can switch between the viewing modes, Google Maps or build plans. Okay, and now let's take a closer look at one of these measurement points. So you need to click on the measurement point to display the detailed information. So first you can visualize the test results, for example, the RSRP, RSRQ, SNR values, the transmission power. Each time we perform a network test, the application automatically geolocates the measurement points using the GPS of the smartphone. So you can validate the automatic positioning of the test points, or you can adjust the position manually if you need. It's also possible to position the measurement point on a building plan you have imported. And you can add any contextual detail, take a photo of the testing site, for example, the meta location. You can add a comment. So all these radio mapping projects are made available to you in the form of a Word report that can be exported via the application. So to generate the report that compiles all the test results, photo, etc., you just need to click on the report icon on the mobile app. And here is the report that has been generated for this project, for example. So you have the project overview with name, description, date. You have the measurement points with geolocation, test results, comments for each point. And you have the embedded photo for the visual context, etc. So radio mapping mode really is not just about testing. It's about delivering you with actionable insights, documenting every detail, and optimizing the IoT deployments with confidence, really.
Yeah, absolutely. Thank you very much, Elsa. So as you can see, a lot of interesting things. The radio mapping part, mainly the export part, mainly is really important because more often than not, it can be one person's job to cover radio mapping for a project, but sometimes several people work together. So if you imagine all those people having their own field test device, exporting the results of the project and sharing it then together on their computers, in half as much time, you can cover a lot more ground. You can compare measurements on specific networks. So there's a whole new, I think the LoRaWAN version of the device that we have was, of course, we are still very proud of it. There are new features implemented in this version, the cellular version, that we are really looking forward to receiving more and more feedback about, on. Sorry. So before switching finally to the Q&A section of this webinar, we are going to bother you one last time with a quick quiz about what you have learned on. Let me close this. Yeah, what you have learned on what we said, because we shared a lot of information. So just to see if some of you retain all the information or not, and see if there are questions that we need to respond at the end. I see that we already have some. So I will let you all vote now. Normally you should be able to do so. Yes, perfect. And then we will see. There's no prize to win. There's nothing to lose. So that's
just for fun.
Yeah, making mistakes is okay. We shared a lot of information, to be honest, but it's just to see also what was learned and understood. So there we go. I'll leave you half a minute as well. If you have to drink some water, now's the time.
Yes.
So far, I think we have good listeners, from what I can see.
Yeah, great job.
Yeah, the first one can be a bit tricky, to be honest. So that's okay. We have 6 people that voted. What should we do? Should we close the vote for now to switch directly
Yeah.
to about 4 more minutes? So okay, let's close the vote. It's okay if not everyone participated.
Just review the answer.
Yeah. If we share the results, oh yeah, actually 13. Okay, we did not update. Which key metrics can the Adeunis Field Test Device measure in real time? This one was a bit tricky. It's actually the last response, both A and C. As Elsa said, you can measure the signal strength and the signal quality, but also the noise level.
But not only, you can also also assess the transmission power, the CA level.
It is a non-exhaustive list, of course. Yeah, absolutely. In terms of what the 3 operating modes of the field test device are, promo.
Oh yeah.
I'm trying to make everyone participate.
So yes, the second answer is a good one. So the network send, network test, and the radio mapping project.
Perfect. Then what makes the radio mapping project particularly valuable? So we asked this question in a bit of a biased way, of course, but we love our device, so that's okay. Indeed, it allows geolocated tests, comments, photos, and professional reporting. That was correct. As Elsa showcased in the videos were perhaps a bit long, but the idea was to give some time to Elsa to comment on them, and also for you to take a look and read as much as possible some of the options that were available. Now, how long does the field test device battery typically last? We all know about batteries for IoT devices in general. There's the estimated battery. We have done a lot of testing with this device, and you can at least expect up to 15 days of battery autonomy, sometimes more. Charge completely, of course. When
the 15 days is when you use it like for a normal work day, so around 8 to 10 hours. Of course, if you use it 2 hours a day, it will last more than 30 days.
This, of course.
And the charging time is about 6 hours, so it's not that long.
Yeah. Absolutely. And then last question. What are the file formats available for exporting test results? It was indeed CSV and Word.
But maybe, so nobody answered the JSON, but also, as I mentioned, you can send the test results to an HTTP server. And for this, the format is JSON.
Yeah. So 2 tricky questions. Okay, perfect. So we'll stop sharing the result briefly, bring back the slide about the Q&A, and see a bit about the questions that you asked. I hope it was clear enough. A lot of information to divulge, of course. There are a few questions that I will myself, I'm more here on the commercial side of things, but there are a few questions that I will let Elsa respond to. Give us a couple of minutes. Can you, it's okay, can you read the, okay. We have a big monitor here as well. This is why we are looking this way. Okay, so there's one question about one question from Suhail, if I'm not mistaken. So regarding the LoRaWAN version, LoRaWAN/Sigfox version of the FTD, how can we set up the field test device on the IoT configurator app? So if I am not mistaken, you are really focusing on the LoRaWAN. Very quickly, this can be done. The field test device is a device apart from the rest of our devices. It does not actually need to be configured as much as the other devices, but you can either follow the documentation to do so available on the website, on the device's webpage. Send us an email if you need concrete information. And we also have, as a lot of you might know, a dedicated support team that can help you really step by step, make sure that you are using perhaps the right USB cable, that you are using the right version of our IoT configurator and everything. So I hope that gives you some answers.
So one question about so does the FTD support traffic test? So with the current version, no, we do not support ping test. For example, we have yes a lot of information that you can get, but not the latency using ping. Maybe it will be probably available in the next version of the firmware. Yes, and with that we can make a link with another question. Do you plan to support firmware upgrade on the FTD? So yes, firmware upgrade is supported using Bluetooth, and it's done via the smartphone app. So every time you connect the FTD to the mobile phone, we will check if the device is using the last firmware version, and if not, you will have the possibility to download the last firmware release via Bluetooth, but it's not mandatory. And yes, you can switch the firmware update for next time, for example.
Absolutely. We have Felix Wolf, hi, asking about an estimated price point for the LTE-M field test device. Of course, the pricing. So the pricing will always depend on we have several countries, for instance, attending this. It will always depend on the country, the volume, and all this sort of stuff. An estimated price point as of public price, the field test device, so this field test device with, of course, the free access to the either Android or iOS mobile app will be around 450 euros as a public price. That's the price point that you can take away from this webinar.
And you just have to pay once for the hardware, and then you do not have recurrent.
We are not going to make the application paying. I forgot my English. It's not going to be a service that you're going to need to pay for or any subscription based. Of course, it's pretty much the same as the field test device LoRaWAN, but with a mobile application this time. Once you have it, you can use it. The only thing that, of course, you need to purchase is a nano-SIM card from the telecom operator of your choice, or a multi-operator nano-SIM card as well. You just need some electricity to charge it, of course, the device and the nano-SIM card, and then you are good to go with the mobile app, of course. Sounds great. Perfect. I'm glad to read it, Felix. Do we have any more? It's 48 minutes now. It was supposed to be 45. We still have a bit more time on our side. Do we have any more questions? Was the explanation and the videos clear enough? Let us know what you think. In the meantime, since I see people writing, I am letting you know that, of course, we can also, I think, switch to the last slide with some contact information. Here you can find, if you do not have them already, our contact information. For your very clear, thank you. Perfect. Thank you very much, Francois, for your feedback. For any business commercial information, you can write either to me, as long as it is happening outside of France, of course, or directly on the website at sales@adeunis.com. Elsa is, we are always working together on the cellular product lines, so she will be able to respond to technical inquiries. At the moment, she is also doing demos for the field test device, which you all witnessed today, of course. But if there's a need for a customer of yours or a partner of yours, that should be manageable on our side. So feel free to contact us. I don't know if you want to add something else on your site.
No, thank you.
It's okay.
Thank you.
Great pitch. Thank you. Great. Okay. Thank you very much, everyone. As long as the audio and the video was clear and the information and the English was good enough as well, because we are French. So it's a work in itself.
Your English is good, mine is lost.
It was okay. It was okay. Thank you for the presentation. Thank you, Patrick. Have a nice day.
Thank you.
Glad to see you. You're welcome, Pedro. Okay. We're gonna say goodbye to everyone now. If you have questions, contact us at the email addresses.
Thank you for joining us.
Thank you very much for your time today.
Thank you. Bye.
Bye.